Okay, gang, we're on to section 3.3. So we'll start with the product rule. And so remember, what we're working on now is how to find the derivative. So we're learning a lot of mechanics, the rules on how to do the derivative. And you have to know when to use what rule. So this is the product rule. And you're going to use this when you have a product, okay, when you have a multiplication. Now the thing is when you have a product, it's not as simple as just taking the derivative of each piece. Like just sort of like doing just coming in and just taking the derivative of each piece. It doesn't work like that. So this is the explanation of the rule and how it works. It says here that you leave the first piece alone and you take the derivative of the second piece. Then you add the second piece, you leave it alone, and you take the derivative of the first piece. So since this is a sum in the middle, it actually doesn't matter what order you do this in. What matters is that you take the derivative of one piece, leave the other alone, and then do the opposite. Okay, let's try this. I don't actually care for this one here because, as you know, the derivative of e to the x is itself. And I want you to actually be able to see, I want you to clearly see when the derivative is changing. So let me make up something really quick here. Now, I know I could distribute this and technically, and take the derivative, and technically on a test, that's how I would do it. That's the easier, more appropriate way. But I'm going to leave it in this sort of weird format because I want to clearly show this rule. So the first thing I want you to notice is that this is a product. It's x cubed times x squared plus 5. So because it's a product, in this form, I have to use a product rule. Now, I'm going to use colored pencils because, oh, and I don't like that we're calling it f. Hold on a second, because some people will get confused with which f we're talking about. So let me call this function h. I don't want people to get confused when I reference this rule, which has f's in it. All right, so let me call it the function h, and I'm going to take the derivative of function h. I think that's more clear. All right, now I'm going to follow this order because it's so ingrained in my brain. I'm going to always do it this way. And again, it really doesn't matter what order you do this in. So the first part of the rule again says you leave when you take the product rule, right? This means apply the derivative. D dx, d of this dx means apply the derivative of this in respect to x. All right, so it says leave the first guy alone. So if you want to think of this as like f and this is g in terms of this, that's the transfer of the concept. All right, so I'm going to leave f alone. So f is x cubed. Now it says take the derivative of the g part. So that's this part. I'm going to take the derivative of that. Now again, I'm going to do this in color because I think for some people that will help you. All right, so the derivative of this part, the derivative of x squared is 2x. The derivative of 5 is 0. Remember, the derivative of a constant is 0. All right, so that's the end of the derivative for g. All right, now make sure you add. The rule is to add. All right, now I'm going to leave the second part alone, the g. Remember, this is the g here. I'm going to leave the g alone and then take the derivative of f. All right, so this is me leaving g alone. And now I'm going to take the derivative of the f. The derivative of the f part is 3x squared. Alright, this is the most important part of me solving. I'm just now going to go ahead and simplify this. Alright, so I combine this. This is 2x to the 4th. My brain just wanted to distribute it this way. Whichever way you do it is fine. You're going to get the same answer. Okay, 5x to the 4th plus 15x squared. Alright gang, that's it on that one. Now I'm just going to make up another one for you. And feel free to stop it and try it and then check with me if you'd like. See if I can get that lighting a little better for you guys. Yeah, that's better. Alright. Movie making at its finest. Whoever thought it would come to this? Oh my god. Alright. Is what it is. Okay. Let me make up something nice for you guys. Let's do trig. Let's practice our trig. Let's do cosine x times tangent of x. Yeah. All right. I hope you find that as exciting as I do. All right, here we go. I'm going to label this guy F. I'm going to label this guy G. All right, let's go in for that derivative. As you can see from my rock star hand here, that is the star of my show. I got a little accident yesterday on it. It's all good, but that's why you're seeing the different attire on my finger today. Alright, so here we go. We leave F alone. And we're going to take the derivative of G. Now, do you remember what that is? I just like to put brackets here. You don't have to put brackets here. You know what? Let me not do that. Somebody's going to go crazy with the brackets. I'm going to get them confused. Alright, let me just leave it like that. Derivative tangent is secant squared x. Okay, so we left the first part alone. We took the derivative of the second part. Plus. Now we leave the second part alone, which is the oh, I said I would do it in color. So I took the derivative of this part. Alright, now I leave the second part alone. And I take the derivative of this. Now this you actually do have to put up a parenthesis at first. Because, oh, flying pencils. Because this is going to end up being negative sine x. So basically you're multiplying a positive times a negative. Basically you're multiplying a positive times a negative, so you have to make this negative tangent x sine x, okay? Now I'm going to circle it here. But I want you to understand that when you check your answer in the back of the book, they may have used some trig formulas, some identities to manipulate the answer. So meaning you have the right answer, but they might just have it put it in a different format. All right. Now, I don't really require you guys to fiddle with the trig identities. If you handed it in like this, this is fine. Certainly, there's other formats to this answer. It could be 1 over cosine cubed minus sine squared over cosine, and then gotten an LCD and combined. Okay, so there's like, if you love trig identities, there's a ton of places to go with these, right? But you're not required to do that on the exam. I just want you to be aware of that. And just be aware, again, as I just said, that it could be formatted differently in the back of the book, but you still have the right answer, because there's many ways that this answer could be submitted. Alright gang, I'm already almost, I'm heading towards 10 minutes on this guy, so I'm going to end this video here, and I'll start up on another one. If you get stuck on any of this, you know, give me a holler. Okay, I'll catch you in the next video. Bye-bye.